Hello, coders, and welcome back to Conquering the JavaScript interview with a different cat than the thumbnail. This is Apollo. Say hi, Apollo. Yeah, he says hello. He happened to be in the room when I was recording this video, so I took the opportunity to pick him up. But in all seriousness, welcome back to Conquering the JavaScript interview. In today's video, we're going to brace ourselves for the challenge of tackling a classic problem, checking if an expression has balanced parentheses, or brackets in this case, since they're easier to see on video. With the right approach, we're going to stack, you'll get that pun in a minute, the odds in our favor and ensure our code remains on the curly path to success. These puns are getting better and better. So let's get ready to open up this curly conundrum, and we're going to close it with a smile, y'all. All right, so this video's algorithm, I guess we're going to call it bracket balancer. Technically, that would imply that it balances the brackets for you, so maybe I picked a horrible thumbnail and title for this video, but it is what it is. Basically, we're going to write a function that takes a string argument consisting of curly braces, brackets, whatever you want to call them. I think brackets are the square ones. So you know what? I've completely bungled calling these things the correct name. Again, get in the comments and tell me how professional I am. #professionalism. And it returns a Boolean if the brackets are balanced or not. So for our input examples here, we're going to see, two pairs of brackets, curlies, whatever, and we're going to get true from that output. This one will also be true because while they're not paired together, there are still an equal number of left and right facing curlies, which gets us true. This one has an odd number. It's basically the top one with one deleted, so we should get false. And we're going to account for some edge cases as well, like if we have undefined null numbers, non-string entries, or empty strings, and it should also just go ahead and return false, throwing in some edge cases to account for in both the tests I've written for this one, as well as the console logs we'll see in this video, right? So, this one is not too bad, especially because we're going to be utilizing a stack data structure. So I'll have that link in the description in the video. I'll have that linked in the description beneath this video. There we go. Where I go over the data structure of stacks. That way you can, if you don't know what they are or can't really define one, go watch that video right quick, even on double speed, and come back here. We'll be using some basics of how stacks work. So to tackle this little conundrum, we're going to pretend we're organizing a party where guests are required to wear matching left and right hand bracelets. So they're going to be showing up with these things. So we're going to be the host of the party, and what we're going to be doing is we're going to stand at the entrance to check all of our guests' bracelets. We have an empty box, which we're going to be using as our stack data structure, just an array in this case, that we're going to use to keep track of the left bracelets, okay? So as the guests arrive, we follow a couple rules to see if they are matching or not. When a guest with the left bracelet arrives, an opening curly brace, we're going to take that bracelet in the box, right? That's pushing it into our stack. When a guest with a right bracelet arrives, a closing curly brace, we're going to look at the stack. If the stack is empty, we know there's no matching bracelets, so this party organization has failed. False. If the box contains a left bracelet, meaning if we pop one out of the box and it has a left bracket or bracelet, losing track of my own analogy, you will take the left bracelet out of the box by popping it out of the stack. And then if we found a matching couple, that means we have him, right? If the box contains something other than a left bracelet, the bracelets are not balanced, and then the party organization is also unsuccessful. Once all the guests have arrived and I've gone through the entire list, I look at the box where I was containing left braces that I was using to join or confirm that there was a matching right one last time. If the box is empty, meaning we have nothing in our stack, it means the all left and right braces were matched and the party organization is success. And if the box still has bracelets left, it means some guests didn't find their matching partners and the party organization was unsuccessful. So, yeah. That is the idea behind how we are going to implement today's little code. So I marked it as intermediate because, again, like if you understand what a stack data structure is, it's pretty not that difficult, and the logic for this one's also not that hard. Also, I didn't feel like recoloring the thumbnail, so I'm going to mark it as intermediate skill level, and we'll punch it up a notch by doing some input validation to make it more than just a beginner type of algorithm video. So let's keep on diving in with our actual code for this one. Like I said, we need to account for a couple of things. First off, that we're going to return false if our input expression here, our string of characters, for example, if it's not a string, then we're not going to bother running anything at all. So we could even say, hey, if the type of our expression is not a string, then let's not even bother. So if we're trying to input numbers into isBalanced, null, undefined, or something like that, then we're not even going to bother because, again, the purpose of this whole expression is looking at a string of these characters. We can also say if the expression length is 0, that means there's no point in running any kind of iterative logic, checking our curly braces, for example, because, well, there's none in there. So that's how we can go ahead and identify and account for this particular input, like an empty string input, to say, hey, there's no point in even running anything because there is no valid input. So there you go. Some quick little input validation right there for checking non-empty strings, or if it's not a string at all, we return false early on to skip the whole process. A little bit of code optimization and bumping this up a tier in difficulty. Right? Or not difficulty, but meaning, like, again, we're going beyond just trying to solve the problem at hand and thinking of edge cases. I say this across all of my videos. I say when you begin pushing yourself into that kind of territory, you do set yourself apart from individuals that code just for the problem at hand. It kind of sets you a tier above the rest. So, like I said, we need to go through each character and also track our left curly braces in our stack. So we're not going to be having to implement like a class object of a stack data structure because if in the video I link below, I'll even mention this, that arrays kind of already have those methods built into it for us. So that's what we're going to be using in our curly brace stack right here. A nice array, we're going to be pushing things into it and popping things off, and that is going to be our stack data structure that we'll be utilizing for this algorithm. Next, we have to loop through each individual letter of our character of our input string here. So that sounds like a good old for loop. So we can say let I equal 0, I is less than expression.length, and then we can do I++, right? So, and then for sake of readability, I could do the following, and I just realized, you know what, I should just go ahead and do a for of loop, since that will do the same thing, since we won't be needing to do any kind of math or checking with the iterator variable I in this particular use case. We simply would like to have a variable called char that represents what is the character we're currently looking at. So we could also just do the following. We could just say const char of expression, and that'll get us that shorthand all nifty for us. And again, I talk about this across multiple videos. If you know you can throw some shorthand in there that removes some additional syntax problems you could run into on a whiteboard if you're nervously writing something by hand without your IDE or your code editor helping you out, because VS Code is not a full... Whatever, I'm not going to get in that discussion right now. It's always nice to have these kind of shorthands to help you out in an interview scenario where you're probably nervous, a little sweaty, a little anxious, right? Trying to answer this question, you might forget a semicolon. You might write a comma instead on a whiteboard. Stuff like that happens. But these make it easier. So const char of expression will allow us to shorthand that for loop right there and that variable creation. So from there, we need to, like my analogy for organizing this party or seeing if the party is successfully organized, we're going to look at that character that we're currently looking at. If it's a left-hand bracelet, we are going to put it in our stack and then start matching it with people that come in with right-hand bracelets. So in the event that the character is a left-facing bracket, we will push it into our stack via the handy-dandy array method of push. Right? Cool. So, and push will always put it at the end of the stack, and we're going to be using the opposite of that, which is pop, which will always remove the last one from the stack, right? So no unshifting to add at the beginning, nothing like that. We're simply going to add it into our stack as it goes along. Then we have to account for another scenario, else if in this case. So not just some dangling if, we're going to check for a secondary case, which is if it's a right-hand bracelet. We're going to say if the character is a right-hand bracelet, then we're going to run some additional logic. Like I had said in the analogy, we followed a couple of rules when we encountered a right-hand bracelet. We needed to see if there was anything in the stack at all, because if there wasn't, then there's a problem already. We've gotten a right person with a right-hand bracelet. There's no one with the left-hand bracelet that's come in at all, so clearly this has already failed. So we can say if our stack length is 0, we can go ahead and return false, right? That was, again, You look in the stack, there's nothing there to match with this right-hand bracelet we found here. Maybe we've already gotten 3 or 4 pairs that came through, and all of a sudden we get a right hand with no left-hand curly brace to match it with. Sorry, our organization has failed, so we're going to return false in this case, and we don't have to keep iterating whatsoever because we've already ran out of left-hand curly braces to match with this right-hand one. Next, the other case was if we remove something from our stack. So we pull out what's in our stack, and if it's not a left-hand, if it's something other than a left-hand curly brace, then we can't match with this right-hand one, and we have also failed in our quest to organize this party. So if we pop off something from the array, and it is not a left-hand curly brace, we're also going to return false because, well, it doesn't match our right-hand curly brace rules that we've set for organizing this party, and therefore it's going to return false. Then, ultimately, if we finish this entire iteration, it hasn't returned false. Hello, Percy. My other cat has decided to come say hello for this video as well. Again, owning cats is a fantastic derailment of productivity and a conduit of destruction. There's his tail in front of the camera a couple times. You want to come say hi for the camera, buddy? Percy. You've already gotten this close, buddy. You might as well finish derailing the whole video. Come here, bud. Come here. He's not... Oh, I've found some flea scabs on Apollo, so I had to give him a flea treatment to make sure that they both don't get fleas. I don't want them in the house either. This happens, unfortunately, this time of year. My wife and I take a lot of walks outside and pet the neighborhood stray cats, so I'm not surprised we bring in fleas occasionally. Not much you can do, but I put some treatment on their back, and they're not happy with me for it. But, hey, buddy, come say hi. This is like the second time this week you've come by and said hello to the video. So, yeah, this is actually the cat in the thumbnail. This is Percy. He destroys everything he touches somehow. Good boy. Anyway, like I was trying to say before we were so cutely interrupted by my kitty cat, if this entire loop finishes its task and there's nothing left in the stack, that means, yeah, buddy, we have matched every left and right hand curly brace. So we're going to return a Boolean value here only if our stack's length is 0. That way, if there's nothing left, it will return true. This is a balanced curly brace expression. If there's something left in our stack, that means we did not pair up every single left and right-hand curly brace correctly, which means, oops. This will then evaluate as false because there'll be something left in our stack. And that right there, folks, is the, well, I think that's the entire thing, if I'm not mistaken. So yeah. We do some input validation, good stuff always to start including more and more of as you progress in your abilities to tackle these algorithms and prepare for your interviews out there. We initialized our stack, which we understand is just an array with 2 important methods, which will be push and pop. Right? We loop through and we do a shorthand to get each character of our expression, which again, we understand that we can get characters from an string, kind of like index positions from an array. We handle the opening curly brace, right? We push it into our stack. That's going to be collecting the left-hand curly braces. So when we see a person come up with a right-hand one, we then see if the character is a closing curly brace. We check the following conditions. If there's nothing in our stack, that means we can't pair this right-hand curly brace, which means, oops, we have messed up. There's no matching left-hand brace, so we can return false. If we pull something out of our box of curly braces, aka pop it out of our stack, and if it's not a left-hand curly brace, then whoops, we can't match this. This is a mismatch of braces, which means we have something going on here, which means we return false as well. And then, like I said, in the final result, if there's anything left in a stack, that means we didn't match everything correctly, which means it is also false. But if there's nothing in the stack, we haven't returned false early, then boom, this should be true, which means, hey, this is a balanced curly brace output. So let's take a look at some conditions and some console logs here to see what we get. So, bada bing, bada boom, let's check out this one. With any luck, I should get a true. This is indeed a balanced curly brace solution. Like it, love it. Let's go, let's go. Let's copy the second one, which was another slightly more complex example. All right. Which, again, it should be a balanced curly brace true output. That's what I like to see. And then we're going to have our false one, which is just the same thing with a missing curly brace to test it with here. Whoop. That should be false. That's what I'm talking about. And our bad input, or an input of numbers, or an undefined input, for example. Stuff like this. We got to make sure some of our edge cases are handled here. So we should see true, true, and then false, 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 false. And the next output here, hit the S in the wrong place. There we go. Ooh, that's not what I, hold on. Oh my God, I'm stupid. My mistake, everybody, my mistake. I did not call the function. I was like, that's not what I expected to see. I was like, why is it returning my input to me? That shouldn't be the case. It's because I just simply console logged those values like a dummy. If you saw me doing it and were yelling at me, call me out in the comments. Oh my God. Okay, there we go. Now we should really see what I was expecting, which is, yeah, 2 trues and 4 falses, because you probably, I'll get a screenshot of my face going, huh? What happened over there? That's not right. I like how my initial gut reaction was like, no, my code is fine. Something's wrong with this console log. Thank you, Percy. Don't just mess up my and he runs away. His tail was going to sit there and flick across the camera. Anyway, again, I like how my gut reaction was to go, no, my code is fine. Something is wrong with this terminal. So I restart the terminal script with an npm run dev, and I'm like, wait, no, something is wrong with my code because the output's incorrect. It's because I forgot to call the function with those inputs. I just console logged them. So yeah, my mistake there. But there we go. That is our algorithm for this video. Hopefully it makes sense why we tackled it with this data structure right here, simplifying the whole process of being able to compare these curly braces to see if they're balanced or not. And once again, I have the exact same like outputs covered in some tests for when I do make this into its own repository. Boom! It is indeed is balanced. So yeah, the big O for this video, both in complexity and space, is a big O of N. I think y'all are probably getting pretty decent at defining what this is and looks like, simply because we now know that if we have an input that we iterate through at least one time with no nested if statements, a lot of the times it does default to that big O, which is that linear line right there. Because the bigger our input expression gets, the longer will take to iterate through each character of the input. Same thing for the space of the big O notation for space on this one, because that stack could potentially be as long as our input is. If it's a bunch of left-hand curly braces, a very long input of left-hand curly braces, the stack will grow with the size of that input. So big O of N for both the complexity and the space on this one. So yeah, what else is there? I mean, why is this cool? It's something I've been trying to include on more and more of these. This one seems like a goofy algorithm to try and tackle, like, what do I care if curly braces are balanced or not? But if you are a JavaScript developer, you probably have dealt with JavaScript object notation or JSON. So any kind of text editors, IDEs, linting tools that you probably have installed on your VS Code editors, or you've done with any kind of Bootstrap project like Create React app or whatever to have linting tools. These are all algorithms that run behind the scenes that have to make sure that you've closed curly braces correctly. Because if I don't close curly braces correctly on my project, a lot of the times I will get a red underscore saying, hey, you got something going on here. And then the editor knows something is wrong with my number of curly braces because it ran fundamentally this kind of an algorithm, right? I think that's pretty cool to think about, that something you use all the time in your daily coding is done fundamentally with something like this. Like, that's the idea behind it, right? In any kind of HTML validation, opening and closing tags have to be a match. Probably runs fundamentally something like this as well. Compilers and interpreters for programming languages, right? They will tell you if there's a syntax problem with curly braces, parentheses, semicolons, etc. before it actually compiles. Voila, this is that fundamental concept that they run on, right? So beyond, again, passing your interview and becoming a better problem solver, putting more tools in your tool belt, this is a pretty cool thing behind the scenes that you've been utilizing the whole time without even knowing about it, right? So, as always, y'all, thanks for watching. I hope you found this video helpful in you and me, that's right, our journey to becoming better developers. If you enjoyed this video, consider giving it a like and subscribe to our channel, hit the bell, all the YouTube stuff, whatever. Also, I'd love to hear your thoughts on this algorithm. If you have an alternate solution of any kind, leave it in the comments down below. Remember, being constructive and positive is always welcome here. Let's keep this discussion going and help each other improve our coding skills. Thanks again for tuning in, and I'll see you in the next video, and maybe we'll have yet a third. Oh my goodness, so many appearances by Percy today. So Open with one cat, close another cat. I'll see y'all in the next video.